Right. Integration today. Today is all about exponential function, alright? Or E. So, you must be able to integrate simple expressions involving the exponential function using the fact that if I integrate e to the power of x dx, it is equal to e to the power of x plus c. Plus c so that we have got the family of curves. Alright, could translate up or down. So, the next bit is you must be able to integrate e to the power of fx, where fx could be either linear or non-linear function. Now, anti-differentiating e equals to e to the power of fx when fx is linear. First, we know that d dx e to the power of kx is k e to the kx, right? Written here. So, therefore, when we have integrating e to the power of k, x dx is actually 1 over k e to the power of kx, because if you integrate that, it is actually k times 1 over k e to the power of kx, right? Yeah? So therefore, if you integrate that, you integrate the expression, you get e to the power of kx. So when you differentiate that, you get e to the power of kx, and therefore when you integrate e to the power of kx, you must have the 1 over k. Alright? Now, the next bit I want you all to think about, how about if I integrate e to the power of ax plus b dx? What would happen there? What do I do when I integrate e to the power of ax plus b? I do a differentiation of e to the power of ax plus b. What happened? That will give me e to the power of ax plus b, correct? So what would happen here when I have got integrating e to the power of ax plus b dx? What do you need to do? Okay, let's have a look. If I do dx of 1 over a e to the power of ax plus b, what would happen? That becomes e to the power of ax plus b, correct? Yeah. So therefore, when you integrate, you need to have the 1 over a. 1 over a to the power of ax plus b plus c. Alright, so that bit is important. I've proven to you if I do a ddx, that is what happened. So when you integrate back, you need 1 over a of the coefficient of x. Alright? Now, that is anti-differentiating fx where fx is linear. Let's do some example now. Start off with the very first one. Determine y if dy dx equals to e to the power of minus 3x. So sometimes when you do something like this, you can think about, what do I do when I differentiate e to the power of minus 3x? When I differentiate that, what happened? So if I differentiate d dx e to the power of minus 3x, we have minus 3 e to the power of minus 3x, correct?
Yeah.
So here, when I differentiate that, I need to think about what is the coefficient that's required in front. Alright, so I could write dy dx equals to minus 3 e to the power of minus 3x multiplied by 1/3. Negative 1/3, correct? Because minus 1 over 3 times minus 3 will give me 1, which is, there is a 1 in front. Think about how you could manipulate this term so that it looks something like the differentiation of e to the power of minus 3x. Here, let's think about how you could actually differentiate this, and this. How are you going to write this? If I've got e to the power of 2x, if I've got to differentiate that, and if I differentiate e to the power of x over 4. What has to be in front of that? What has to be in front of that for that to happen? So you got to think backwards. All right, you got to think backwards. Now, the other thing you could actually do is, you know that in that case, I can actually write this as e to the power of 2x dx plus integrate e to the power of x over 4 dx plus integrate minus 4x dx. Right? So think about how you would do this. You can do it separately, or you can think about this. What are the coefficient of e to the power of 2x or e to the power of x over 4? I mean, for me, I tend to like to do it this way. Each one separately. So I know d dx of that is half, it is half 2, actually it's 2 e to the power of x. So therefore, I can write the first term as integrate half 2 e to the power of 2x dx. Right? So think about deriving e to the power of 2x. What does it look like? And how you are going to convert from here to here. All right? To the same. This is basically the same value as that. I just changed the appearance, that's all. All right?
Why would you change it like that?
Sorry?
Why would you change it like that?
Because I know that d dx to e to the power of 2x is 2 e to the 2x. If I just integrate e to the power of 2x, we don't know what it is, unless we know that. See?
But why can't you just like differentiate from the first? Why did you need to do?
Sorry?
Why did you need to do a rearrange it?
You need to do that because if not, you don't know the coefficient of the. You can't integrate it. You don't know how you could integrate e to the power of 2x without knowing that. You could integrate that, but you really couldn't integrate that unless you manipulate it. Yeah. From there, you need to go from d dx to your, you got to differentiate it first and then think about how you reverse and take it back.
Yes.
That's all. All right. More. What about this? How would you do 3? Now 3, I will probably rewrite it as integrate half e to the power of minus 5x dx. All right?
Keep feeling positive.
So the back of my mind, or on a separate piece of paper, I will do d dx e to the power of minus 5x. That will give me minus 5x. Minus 5 e to the power of minus 5x, not 5x. Yeah? Now, how on earth are you going to link this to that?
He's doing something.
How on earth are you going to link this to that?
1 over negative.
Yep. So, what you would have is, you need that, correct? So you need 5 e to the power of minus 5x.
You're right.
Yeah? How do I get from here to here? How do I get from here to here?
Oh, you
8
can
minus
multiply.
1 over 10.
Yeah.
Correct?
You bring it out, yeah.
Yeah? So you got to work backwards. You got to think about how you go from e to the power of minus 5x to that.
7.
And then think about the coefficient here
Expanded into.
and link that to the,
Really?
So it's e to the power of -5.
link this minus 5 to the half. How do I get minus 5 to half? I need to multiply by minus 1 over 10. Alright, you need to be able to work backwards. Work out the coefficient. Yeah?
Yep.
So if I do it that way, I've got half e to the power of, it should be minus half, sorry. It should be a minus half.
Why? It's possible.
Oh, so it's minus 10. Sorry, it's my fault, it's minus 10. Oh no, hang on. No, I just rewrote it that way, so that's it. It is minus 10. So that's still the integration. Alright, it's still an integration. So from there, this is how I get it. Which then it will become minus 1 over 10 e to the power of minus 5x plus c. Alright, you can always work backwards. Can you try number 4, please? Use the technique I showed you. Try number 4, please. Think about
So we go for 7.
what is differentiating e to the power of 3 plus 4x and differentiating e to the power of 3x.
And it's
Alright? Think about that first. How are you
Oh,
going to
it's minus
differentiate that? If you differentiate e to the power of 3 plus 4x, what is the end result? And how do you work it backwards?
Would you have to simplify those fractions?
Hmm?
Would you have to simplify and add those fractions?
12.
I can show you.
You're going to multiply those fractions.
I know it's
Unless,
easy.
you don't. Yeah.
There's gotta be something to do, like a rule to do it.
Did you add those fractions?
For what? For 4?
Wait, 8. Oh, here, 8. Yeah. Here's literally one line I did. Because when you differentiate x squared, you already have that there.
Oh, because 2
You're alright with that
This
so
is just
far?
in the form.
So you just gotta remember.
What am I doing?
Is there not like a formula you can get, or you just gotta know?
Dx.
So, now,
right.
if you look at this,
So it's like that.
what I've done is,
Right.
I've actually thought about from here. I thought about what is d dx e to the power of 3 plus 4x. Alright? That is 4 e 3 to the power of 3 plus 4x. Correct? So, rewriting this.
I mean, if you got it right,
This
you
will
do
be
whatever you want. Do whatever you want. I mean, yes.
1 over 4
I just like
times
did
4 e to the power of 3
It
plus
makes
4x.
sense to just do it.
Yeah,
dx.
you just take the 3 plus
Yeah?
4 again.
So here, this is actually that.
I don't know.
This is differentiating, differentiated. E to the power of 3 plus 4x will get that. So therefore, this is 1 over 4.
A lot of people
4
do
e to
integration
the power of 3
differently,
plus
so just
4x
Do the.
dx,
Put it in.
which is 1/4 e to the power of 3 plus 4x plus c. Alright, if you just only look at one side. Whereas the other one, 2 to the power of 3
But remember your plus CA.
e to the 2 times e to the power of 3x. If I do a ddx of e to the power of 3x, that equals to 3 e to the power of 3x. Now, how do I get this to that? So I need, when I write that, I will have to write integration 2 times 1/3
Just expanded.
times 3 e to the power of 3x dx. Alright? So that bit here will give me e to the power of 3x, whereas this is just a coefficient e to the power of 3x. Alright? Add those together and plus c. Are you alright with that? Yeah? Alright.
Classic crab claw.
Clean that. And we'll do something else.
6e to the power of 3 is you add the coefficients. So you add the powers.
Let's keep going.
What's 48?
Now, what about this? How on earth are you going to do this?
Who knows?
Oh, you do.
You give up. Bro, 48 divided by 6.
Now,
8, right?
Here, how are you going to split this? E to the power of 2x minus 1 over e to the power of 3x. That is e to the power of 2x divided by e to the power of 3x minus 1 over e to the power of 3x. Split it. So therefore you've got e to the power of minus x minus e to the power of minus 3x. Got it? Yeah? So now, from here, how do you integrate?
No. That's 6e to the power of 3. What is
So
it?
you know that
E is just a number, right? So it's like a coefficient.
this
So all it is just
is actually integrating e to the power of
no.
minus x
E is like a
minus
number, like
e to the
27.
power of minus
So it's
3x
27.
dx. Right?
Yeah, 6e to the power of 3x. You get.
I'll give you a few minutes to try it out.
Because E, right, is just a number. So it's like
Think
it's
about
like having that
dx of e
plus
to the power
27
of
and integrating that.
minus x
The
and e
integration
to the
is
power of
27,
minus
which is
3x.
27x, right?
Yeah.
Yeah, it's the same thing, yeah.
You got 12, did you get e root 2 over 2?
Huh?
Yeah, that's fine, you got it.
Easy.
But I simplified it.
So I've written it out on the whiteboard one way and I've written it out on my
since the
PowerPoint the
coefficient
other
is
way.
one, you
It
just
is
put
fine
over
as well.
one, and
It's actually basically the same
you know
thing.
how when you do the power rule, it's like the coefficient is 6. Yeah, and then
So you will still get this
over
bit.
1, because x
Alright?
is to the
When
power
you
of
come up here,
yeah.
how do you do this? This is what you need to know. So let's think about what is dx e to the power of minus x.
Where there's no negative.
That is minus e minus x. Correct?
Definitely a negative.
Yeah? And what is dx of e to the power of minus 3x? That is minus 3 e to the power of minus 3x. Do you all agree?
Oh,
So
no,
what do I
I
need
didn't
to do?
miss the I missed the negative.
Here, I need
I'd
to
rather
put
go
in
with
a
negative.
negative in front. So I have got negative times negative e to the power of minus x. Yeah? dx.
Why is that possible?
Now here there's already a negative.
It's negative here.
So what I need is a 1/3
Just to make up
and a 3
Do it.
e to the power of minus 3x. Yeah? Or I can rewrite it this way, slightly different. Plus 1/3 minus 3 e to the power of
Yeah, positive 2. Positive
minus 3x
yeah.
dx.
So when you do the differentiation, it's minus 1
So
on the front.
minus times minus, minus 1 times minus 1 is positive.
So remember
That
you
is the
times
same
by
value as that.
differentiation of the power.
Plus 1 over 3 times
So
minus
it's
1/3 is
negative
minus
1
1. So
times
that's the same as that.
negative
However,
2, which would be positive
here,
2, what? Negative 2, right?
you integrate that, that will become e to the power of minus 3x. You integrate this bit here, it will become minus e to the power of minus x.
Yeah, so it'd be.
So therefore,
um,
what you
so
get
it'd be
is
plus, yeah.
something like this. Are you happy with it?
Yes.
Yeah?
Yes.
Let's try the next one,
X,
please,
and
D.
then X, yeah, and then plus C.
Try not D, try number 6, please. I am not going to say anything.
It gets easier than that.
Just look at it and then you get it.
Yeah. Well, I mean, can they even? They can't give you a harder question.
No, there's definitely harder questions.
Is that definite? What's this? This is the last question. So can I go get a drink of water? What'd you say? Do you want me to fill it up? 12. It's not that hard.
Which is the hardest one?
Do you want me to fill up the drink water?
Oh,
Alright, here, I took the 10 out. It really doesn't matter you do it that way or not. And therefore, I know I have got, you know that integrating e to the power of half x plus half is actually half e to the power of half x plus half, or half x plus 1. Alright? Alright? So therefore, you need to be able to work backwards. How do you get your 10? which is 20 times half. Are you all okay with this? Yeah? If you are, I'm going to go to the next bit, which is for non-linear. Looking at non-linear. So this is linear. Linear, you've got to be able to manipulate the coefficient in front of e to the power of something. Alright, e to the power of fx. Now, actually, try this please. Determine this. How are you going to do it? Thank you, expand. Expand, and you need to know your index laws.
Oh, very difficult.
No, it's not that bad. Come on.
No,
Cheating's the hardest. No.
You should know how to expand this. You should know how to expand this. Expand it.
2x plus 1. Now, look at the power here. Do you notice anything combination?
Expand it. Once you can expand it, you should be able to have something neat that you can do.
What happens if you differentiate the power?
No, it's x plus 9. X plus 1.
You need your binomial expansion for this.
What happens if you differentiate the power?
2x plus 1.
Yeah. So, if you just have e, x squared plus x plus 2, and you differentiate that, you get this one. So if you want to reverse engineer that, it'll just equal this one.
So the first two terms,
That way it's kind of bad.
if this is multiplied by that, what would happen?
Plus x.
2 times 3 is 6. But what happened to the power?
So,
It's this plus that, correct? 2 minus x plus 1 plus x. Alright? So this is how you expand it. Expand and make sure that you know your index law. You can see that it's very much using your knowledge of year 11. Once you've got that, you know that you can add this. You know that's 1 plus x, this is 2 minus x. Therefore, you've got something like this. Alright? So here, 2 minus x plus 1 plus x plus x cancel out. 2,
He hasn't- he
that's
hasn't
6e
he hasn't
to the power of 3.
he hasn't-
And that is just constant, correct? You don't change, there's no x involved with that. Those two are just constant. Yeah? You know that those two are just constant. Alright?
What are you hitting?
Power of e to the power of 2x plus e to the power of
Legs, come on.
1 plus x. That cancel off. 2 plus 1 is 3.
Yeah, I did just
Yeah? Got it? Yes?
25.
And if I have something like this, and negative x,
You know, just do this. Yeah.
it's just a number.
No, you can't. There's no e here. So that's 6. 6
Yeah,
to the
yeah,
power of 3 minus 1. It's just a number, but you cannot use 6e to the power of 3. Take away 1. That's 1. That's not e to the power of 3. Alright? So,
My chest is not as strong.
if you do that,
I do like 60.
fx, not f dash x. What did I do? So that shouldn't be that. Alright? It's fx is that.
He showed me this is when you start from.
Oh,
So that's what you use.
yeah.
Because
He doesn't do much.
here, that's fx. This is a constant, 6e to the power of x. Alright? Minus 1x. Here, you know that e to the power of 1 plus x, differentiating that is e to the power of 1 plus x, and 3 is there. So it's the same. This is the same, except you need to change the sign, that's all. Alright, let's go to the next bit. Are you all okay with it? Yeah? Next one. Oh, I got an extra step, but you don't have to worry about that if you don't write that, that's fine. I'm not that worried about it.
What? Wait, what?
So I collected the like term, 6e to the power of 3 minus 1 times x. But that's not an issue if you don't do that. Alright? Now here,
Fancy.
anti-differentiating e to the power of fx when fx is non-linear. you need to really think about what is in front of e to the power of fx. All right? That should be a derivative of that. All right? If there's a derivative of that, you can straight away integrate that as an e to the power of fx. So sometimes, again, you've got to manipulate this until the constant is the same when you integrate that. All right? So you've got to make sure that how you work backwards. So let's try this. So here, the first one. Looking at number 8, example number 8. You know that dx e to the power of x squared is actually 2x e to the power of x squared. Correct? Yeah? So if you integrate that, what will happen? It will give you back e to the power of x squared, correct? So you need to really think about what is this? How this is related to the first derivative of that. So you know that this is deriving that x squared gives you 2x. Same with this one, you got to think about how you do it.
Yes, you got to bring
You've got e to the power of x squared plus x plus 2. Okay? That's not actually a formula.
Oh yeah, that's the formula to get it, right?
It's just
Isn't that what it is?
so you need to be able to
No.
Oh, 8 E. Oh. Yeah, that's right. Yeah. Oh, let's go. I'll hit my head as well.
But in your work, you just factor out the 8 first. So you get the 6 there, and you can show that you're getting that. So like, yeah.
Alright. So you need to really observe that this is the derivative of that. Alright? So this 2x plus 1 is actually the derivative of that, correct? The derivative of the power of e is 2x plus 1.
Form, so when you differentiate that, you get that front.
Yeah? So once you've realized that, you can straight away write down what the antiderivative is, or the integral is. E equals to x squared plus x plus 2. Alright?
These mate.
So main thing is recognizing what is in front of e.
I like it, Jules.
What is the function in front of e? Now these are all the small basic example. Let's have a look at this one here. How would you do this?
12 is kind of.
How would you do this?
I'd say it's hard, but I mean, I can't really say anything because I do spec. It's different.
How do you do this? How do you integrate e to the power
I
of
guess it's
minus
pretty hard. So first thing
x
you do,
cubed? d dx
do 1 on.
e to the power of minus x cubed is actually minus 3x squared e to the power of minus x cubed. Correct? Now, how do you relate this
I just like split it up.
to 6x squared? That's what you need to think about. You've got the x squared, but this is 6. This is minus 3. How do you manipulate this until you get minus 3? That's what you need to think about.
I separated it like that. So I made it on T.
Right? So think about a number. 6 times something will give you a minus 3.
What do you need
6 times something will give you a minus 3.
when you times like this?
So the something will be minus
Jules,
half,
I fucked
or
it.
minus
We
3
fucked
over
it up.
6.
Fucked it up.
Which one?
Correct?
Wait, this one, no.
So you can rewrite that.
Do we actually?
I think so, yeah.
I don't think we did.
No, we did. Because the differentiation of t to root t equals half t.
So rewriting it
So remember, the differentiation of root t,
is minus 2 times minus 3
right?
to the power of x squared.
True.
So therefore, what would I do?
Half t.
I can straight away integrate that. Now, what I want you to think about is, in this example, we observe that we have an integral of the form of k times f to the power of x. Sorry, not f to the power of f dash x. The first derivative of fx, e to the power of fx, dx. So in this case, you'll need to consider a scalar multiple of the function
You got it, bro. You got
in the
it.
power when integrating.
Where's that in?
All right.
It's just like
Think
the negative
about
to the
how you
front.
manipulate that.
Scalars
So
are
you now
not
know,
variables, so it's like not a
you
negative.
do know
It's just
that
like a number.
d dx
Huh?
e to the power minus x to the power 3 is minus 3 e to the power of
Yeah, it's not a
Wait, is that
yes,
it?
it's not a constant.
minus x to the power of 3, 3x. All right. So in order to get from minus 3x to
You solve for x.
6x squared, I
So I'm
need
solving for
to
the coefficient
multiply
in
minus
front.
3x
Right? So
by-
the differentiation
Ah,
of root
3x
t
by-
times the coefficient of the front will get me
Minus 2.
1
Right.
t here.
So therefore, I can take the
Understand
minus
that?
2 out.
So I'm solving for the coefficient to
All
get
right.
it to that.
Or think about what you could
Yeah.
do: 6x squared.
So I just solved it.
How do you get there? 6x squared times half
So what's your answer?
equals to 3x squared minus 3x squared.
T on this.
So therefore, to get from 6x squared to minus 3x squared is minus 2 times minus 3. Think about the scalar multiple and play around with it. Make sure that you know what you can do. All right, let's try 11 and 12, please. I think that's last two. Try 11 and 12, please.
12 is a good one, eh?
12 is a really good one.
Cheeky one.
12 would probably be a possible question in the exam. But now that you have seen it, well, if it comes out of waste, that's fine.
But I swear it was still right in the first one.
You just want to look, differentiate that, times it by the differentiation of root t, and you get that, which is where you have that. If you have t on the bottom, you'll have like, you'll get times t here, so right? You have t on the bottom.
All right, what is differentiating e to the power of 2x cubed? How do you differentiate 2x cubed? Differentiating 2x cubed will give you 6x squared, right? So, and how do you manipulate 6x squared until you get to 48x squared?
So have you done, no, Jules, have you done 3B yet? Jules,
Yeah, he's a satellite god. He's a satellite god.
Jules, have you done 3B yet?
3B, yeah.
Have you?
Yeah,
I did all up to 22.
Have you done 25 yet?
No, I did all up to 22.
Nah.
I couldn't be
Fine,
bothered
yeah.
after that. Then it
Nah,
just
fine.
gets too tricky.
I did up to,
Now,
I did question.
so everyone knowing that
25. You want to go
differentiating
25.
2x to the power of 3
I'll touch on
is 6x squared.
Yeah, you're right.
Think about the chain.
So
rule,
I
25.
do know that
Just think about it. Just think about it.
d dx e to the power of 2x cubed is actually 6x
right.
squared e to the power of
Yeah, mate.
2x cubed. Alright? In order to get this to 48
gotta,
is
like-
6 times 8.
If you do it the first time, you
Correct?
just gotta check.
So therefore, you've got a scalar multiplication of 8.
My first callus ever.
You can always bring the 8 out. That's fine. Alright?
We got one.
how do I get the
So doing the integration, you now know
Swimming, raise your hands.
integrating e to the
Yeah,
power of
you
2x
have-
cubed is the same as that. Sorry, differentiating e to the power of 2x
I
cubed
love
is that.
yeah.
So integrating this will give you e to the power of 2x cubed, right? So you got to remember dx equals to something. All right, and you integrate that. Integrate your d dx. It will give you sorry, d dx equals to f dash x.
Wait, let me do
So
this.
if you've got your f dash x integrating at that will give you back your fx. can you try 12, please? I really don't want to show you what I do with 12 yet. I want you to think about what you could
Okay,
do.
so the reason, so how I got this right, or when doing this back,
Actually, no. This wall.
Write
Do
t
you understand?
in terms of
I don't understand why, but
of
yeah, so
don't use a radical in terms of a power.
Yes, because
Do not use a
power
radical.
and then none.
Oh, hang on. Then that's that. That's the answer.
But just
12, try to write it as a power
then you consider that as well, yeah.
rather than a radical.
You need a times above to do that to get it.
this
So
we
we-
want to add.
Yeah, yeah. So the first step you got to do is
Yeah,
add-
because they would times with this.
Yeah,
times
yeah.
with that. Actually,
So yeah, the first thing you should do is add 1 to the power,
Yeah.
and then from there you can reverse engineer it. Yeah.
I did actually.
So if you do that, what I've done is written it this way. T to the power of minus half,
Oh, sir.
e to the power of t to the power of half. Alright? If you write it in terms of power, it makes so much sense rather than in terms of radicals. I don't tend to use radical,
Oops.
so therefore I've got knowing, forget about this yet, alright, knowing d dx or d dt, alright, e to the power of t half
And in the form.
is actually half
Did you do that?
Sort of. I mean, I did it in my head, but it's probably a better way to.
t minus half e to the power of t
Bro, I
to
just
the
like,
power of half.
I
Alright,
just like figured it out.
so I can manipulate that so that here it will appear
I just
to
solved
be
the
something like
coefficient.
this.
Why?
And therefore,
Because
Really would.
yeah, I just
I know that the integration is 2e to the power of
yeah, I got it.
t to the power of half plus c. I think that's the last example I have for you.
Yeah.
So I know you've got to really think. These are the steps that you need to really think. How do you work backwards? Alright? You've got to be able to have these skills because when you come to doing a trick, you've got to go back, think about what is integrate, doing whatever you call it.
This one's 53
this
and this one-
differentiating what is inside the, for example, cos 2 pi
If you do it really
2 pi x plus something, that sort of things. Alright, think about what's in the bracket and what's outside. So here, you must learn how to work backwards. So I've given you quite a bit of work to do with this one. I think it's Sadler. I've done quite a bit of it and I did quite a bit of mistakes. Alright, being really careless.
Like me, sir.
Do you want me to push you?
Try not to be.